Hello everyone, welcome back to my YouTube channel. In this video, we shall learn about the UV-Vis analysis, especially on the determination of the mass of the sample in the UV-Vis. In a UV visible spectrometric analysis, the absorbance of potassium dichromate solution at 350 nanometer was measured to be 0.08 using a 1 cm path length UV-Vis. The molar extinction coefficient or the epsilon of the potassium dichromate at this wavelength is reported as 1500 liter per mole per centimeter. For a solution with a volume of 500 ml, determine the mass of potassium dichromate in grams necessary to achieve the recorded absorbance. For this question, we are going to use the Beers-Lambert law. So the absorbance is equivalent to epsilon BC. The absorbance is given to you in the question, which is 0.08, and the epsilon is 1500. The path length is 1 centimeter, leaving you with the concentration to be determined. So the concentration should be equivalent to 0.08 divided by 1500 with the unit of liter per mole per centimeter times 1 centimeter. So you will get your concentration is equivalent to 5.3333 times 10 to the power of -5 mole per liter. So this is the concentration that we get from the UV-Vis. So from here, the concentration, you can get what is the number of mole by using the formula of molarity is equivalent to mole per liter. Alright, so from the calculation we have done just now, we know that the molarity is such, and then we want to get what is the number of mole and what is the liter is given in the question. Here is 500 milliliter, so 500 divided by 1000, so you will get your number of mole is actually equivalent to 5.3333 times 10 to the power of -5 mole per liter, and then you need to times 0.5 liter. So here you can slash this out, and therefore you will get the number of mole for your potassium dichromate is equivalent to 2.6667 times 10 to the power of -5 mole of potassium dichromate. But this is not all, because you were asked to calculate in grams, so you have know what is the number of moles, so you can get the mass by using the formula. Number of mole is equivalent to mass over RMM. Alright, so now we are going to calculate what is the relative molar mass. So the first thing that we need to look upon is the formula for potassium dichromate. So K2Cr2O7. So from here we can calculate the RMM. So you have 2 potassium, so 2 times the atomic mass, not the atomic number, okay, the atomic mass, which is 39.0983 gram per mole, plus, so you have 2 chromium, so 2 times the chromium is 51.9960 gram per mole, and your oxygen, you have 7 oxygen, so 7 times 15.9994 gram per mole. Right, so when you have put this in your calculator, supposedly you know that the relative molar mass is equivalent to 2.9418 times 10 to the power of 2 gram per mole. Right, this is just the relative molar mass. Therefore, because you want to find the mass, so mole, the number of mole is equivalent to mass over relative molar mass. Therefore, we can say that the mass is equivalent to RMM times your number of mole. Right, so mass is equivalent to mole times RMM. So the number of mole that we have calculated just now is 2.6667 times 10 to the power of negative 5 mole. And your RMM is equivalent to 2.9418 times 10 to the power of 2 gram per mole. Hence, you will get the mass is equivalent to 7.8449 times 10 to the power of negative 3 grams. So how do I get the gram? So here we have mole and then per mole, so you can slash that out, you will end up with the unit gram. So this is the final answer for this question. Thank you so much for watching this video from the beginning to the end. So I'll see you again in the next video. Goodbye.